discharge just potentially straight to atmosphere out through this hole. So rather than do that, what we can do instead is connect the gas turbine to a steam system. This will increase the overall plant efficiency. Here is a combined cycle power plant. We call it a combined cycle power plant because gas turbines use what's called the Brayton cycle. The Brayton cycle is a type of thermodynamic cycle. The other type of cycle that you'll see when looking at steam turbines is the Rankine cycle. Each of these cycles is named after the person who invented them. In engineering, you'll also see the Otto thermodynamic cycle and the diesel thermodynamic cycle. They're all just describing different types of thermodynamic process. Because we're using a gas turbine that is housed within this box here, and the steam turbine is housed over here, within one type of power plant, we're essentially using a Brayton cycle and a Rankine cycle together, and that's why we call this type of power plant a combined cycle power plant. Very briefly, I'll explain to you how it works. We've got our gas turbine here. It connects on a shaft to a generator, which is housed within this box. And then we have 3 phases of power, which are coming out here. They join to a transformer, and then we send that electrical power to our consumers. We draw air in through these louvres here, and the air will pass through a series of filters before it gets to our gas turbine. We filter the air because we don't want any foreign particles being sucked into the turbine, because that might damage our compressor blades or our turbine blades. So it's important to filter the air. It's also important to de-ice the air to make sure no water or moisture is sucked into the turbine. Those hot exhaust gases, remember they may be at 500 degrees Celsius or 550 degrees Celsius, etc., will be discharged along here and into what's called a heat recovery steam generator, which is a type of boiler. And as the exhaust gases move from left to right along here, they transfer their heat to water, and then the water turns to steam. At this point, the hot gases, the exhaust gases, can be discharged through this hole and to atmosphere. The steam from the heat recovery steam generator is sent to the steam turbine, and then the steam turbine rotor rotates and we generate electricity through our generator here. So one heat source which is used to operate both a gas turbine and a steam turbine. When we do that, we have a combined cycle plant and we increase our efficiency, for example, from about 35% potentially, all the way up to 50, 55, and maybe even 60%.